Getting the center of gravity for a point system. Let's say you have these points, for example. Okay, the center of gravity of the set of these points will have coordinates xg, yg, zg in a way that xg is equal to xi plus 1 plus all the x's of the different points divided by the number of points. Yg, the same thing, would be equal to yi, which is y1, y2, y3, etc. for all the points divided by the number of points. The same thing for zg. Now, from a physics point of view, this will be equal to, for x, let's say xg is equal to 1 divided by m, which is the mass, the sum of all the masses of the different points, which is for each point mi xi, for I equal 1 going from 1 to n. For yg, the same thing, is equal to 1 divided by m, sigma, or the sum from 1 to n to the number of all the points, the mass of each point multiplied by the y coordinate, of course, all of that sum divided by the entire mass. Let's say you have a number of points. Consider 3 points for our example. A, B, and C having coordinates x1, y1, z1 to x3, y3, z3 respectively. So xcg, or the x coordinate of the center of gravity, is equal to x1, x2, x3 added up. So x1 plus x2 plus x3 divided by 3. Same thing for ycg is equal to y1 plus y2 plus y3 divided by 3. Same for zcg. Let's start at first declaring the data structure. This is the point that will have 3 coordinates, type def struct. It has 3 doubles, double x, double y, and z, belonging to the point. Now, we need a function that will return the gravity center for a point system. That point system would be an array of points. We're gonna get these points through the caller of the function, and we're going to execute these equations. For x of the center of gravity, it would be the sum of the x coordinates of all points divided by the number of points. Same thing for the ycg, and same thing for the z coordinate. It will be of data type point, get cg, or center of gravity. It will accept a point vector or point array, PA, and we need to define the length of this array so that we can know how many times it needs to loop through the number of points. Int I, double xg, initialized at 0, so we will be adding these x's to xg, also yg equals 0, and zg equal 0. We need to actually separate them by a comma, and an instance of point G, which is the center of gravity. For I equals 0, I less than len, I plus plus, xg plus equal PA at I, which is the point at this index, dot x. Each time it loops, it adds the x of the new point. Same thing for yg plus equal PA of I dot y, zg plus equal PA dot z. Finally, I need to divide each of these sums of coordinates by the length or the number of points. Just like the equation above, x of the center of gravity is equal x summed up together divided by the number of points. So xg divided equal by len. And let's cast len to double because it is an integer. Now, this can be written in another way, which is xg, the new updated value of xg, is equal to former xg value divided by 3. It is the same concept. Same thing for yg, divided equal double len, and zg divided equal to double len. After that, I need to add these values to g point. G dot x equal xg, g dot y equal to yg, and g dot z equal zg. Finally, return g, which is the center of gravity. Also, I'm going to write another procedure, not a function, that will display each point on one line after prompting the user and getting xyz for each point from him. we need to display each point neatly. Void display point p int index, just to tell inside the output that this is point number index, just for display. So printf \n p of number d has the coordinates %f, 3 floats for 3 coordinates. Don't forget the index here, respectively index, then p.x, p.y, p.z. Going to main, at first declare some variables, of course, int len and int I for the looping. Printf lets prompt the user to enter the length or the number of the points, so to speak. Enter the number of points. Scanf to get the value, number of points, and we're gonna affect that value to len, integer variable. Let's break the line also. Since we're talking about an array of a data structure, I need to declare the size of the array. All right. So I need to allocate the size of this array in memory. Point PA, that's an array of points, is equal to point malloc memory allocate len, which is the length of the array, times size of point, size of how much one point would need inside the memory. So it will allocate for PA array number of points times the size of one point. All right, so for I equals 0, I less than len, I plus plus, printf PA %d.x equal I. We're scanning the values for each coordinate of each point, long float, and %PA of I dot x for the first value. Then printf PA of d dot y equal I scanf LF %PA of I dot y, printf PA %d dot z equal I scanf %LF %PA I dot z. Let's also create some empty space between this line and the next one for each coordinate. So let's display the points that we've gotten eventually. For I equals 0, using same I variable, but resetting it to 0, I less than len, I plus plus, display point PA of I and I. We're calling on the procedure we declared above. Point CG is equal get CG PA len. Finally printf, let's create more space for this line. The center of gravity is CG and %f \n and respectively cg.x, cg.y, cg.z. Let's save it and run. All right, so the number of points, 2 to make it simple. For the first one, okay, 1, 3, 4. For the second point, 0, 2, and 4. So you have the center of gravity. If you add these two x's and divide them by 2, you get 0.5. For y, 3 plus 2, 5, divided by 2, 2.5. And here 8 divided by 2, 4, so it is correct.